Hi, and welcome to this quick tool review. In this review I'll be reviewing a tool I purchased from Shar's Tools, which I've evaluated stuff from them before. I purchased this directly from them because I didn't have one. This is a 5-inch by 2-inch sine bar, and this is pretty much how it came. One thing I will say is that their packaging for the shipping container is just a cardboard box, and it was terrible. Just to let you know, pretty much every time I get something heavy from Shar's and it comes in a cardboard box, it gets damaged. I notice there's a little bit of corrosion on the side here. That's also annoying to me. Won't hurt it too much, but I hate corrosion. Anyone who has watched my channel knows that. It came with an Allen wrench to adjust the rolls, or remove the rolls, I guess, if necessary. And it was coated in oil, which I have removed just before I'm showing you this. First thing probably worth testing is to see how flat this guy is across the when the rolls are sitting flat on the surface plate. And we can see here, this is a tenths indicator, so you can see that maybe a tenth from one side to the other. And over here, also a tenth. So this guy is really flat, which it should be, because the way a sine bar works is the center from roll to roll has to be a very accurate distance. The top has to be parallel to the contact points on the bottom. And then what you can do is use a simple trigonometric formula to calculate what kind of spacer blocks you need to get a very accurate angle. Let me show you. So here's how a sine bar works, in case you didn't know. So a sine bar just takes advantage of a very simple trigonometric relationship. So there is a function sine, which you can punch into a calculator, you put in the angle, and it gives you a number that is the ratio of the opposite side of a triangle to the hypotenuse. So imagine if the sine bar was the hypotenuse. In this case, the distance, the space between the centers of the rolls is 5 inches. Okay? So if I put 5 inches in this formula, I will get sine of theta equals opposite over 5 inches. Or rearranging this, multiply both sides by 5, I will get 5 times the sine of theta is equal to the opposite side height. So let's pick an example here. What if I wanted 30 degrees? Then 5 times the sine of 30 degrees is equal to the opposite side. Well, I happen to know the sine of 30 degrees is 1/2, so 5 halves is equal to opposite, or 2.5 inches. So let's test this theory. So what I have here is 2 Fowler blocks, a 2-inch block, there is the 2, and a 1/2-inch block here, and I will take the sine roll and I will place it on top, and what I should end up with is something that's that is this angle being exactly 30 degrees. Incidentally, the spacing between these rolls is accurate to 2/10,000ths of an inch, supposedly, according to Shar's. So one way I could test this is I have a 30-degree angle block that is ground to be very accurate, and I can put it up next to this sine block, and you will see that the angle matches exactly. I can't feel the delineation other than the chamfering between the edge of the block here, but it is perfectly smooth across. So you can see, using a set of gauge blocks and the sine bar and a very simple formula, which is basically the length, the hypotenuse, the distance between the rolls times the sine of the angle will equal the opposite side, or the vertical distance you will have to raise the sine bar to set a very accurate angle. If you're having problems and your calculator is showing up the wrong answer, your calculator may be in rad mode, which stands for radians. And I don't know if anyone cares, but radians are used a lot in engineering instead of degrees, and 2 pi radians are equal to 360 degrees. So if you ever need to translate between the twos, you can, but I just recommend setting your calculator to DEG mode, not RAD mode, and it'll probably make things simpler for you. I chose this particular value because I knew that the sine of 30 was half, so that made everything really easy and the numbers work out nicely. But you can just take your gauge box set and build whatever size you need to within possibly 10,000ths and get an extremely accurate angle. So here are some uses for the sine bar that the reason why I got it. One use for the sine bar would be to set something in the vise at an angle. Now this sine bar is kind of thick. They make a smaller version that's only 1 inch, and if you're going to use it in the vise, the 1 inch version, which is also thinner, might be a better choice. This lets you set something at a very precise angle in the vise. Another use that's not as obvious would be to put the sine bar on its side and set a very specific angle. Now you're thinking, oh, I can't clamp anything in here, it's just going to squeeze it right out. But what it would be used for would be if you needed to mill an angled slot on a piece of material or a piece of work, and you need to cant your vise. How do you get your vise at a very accurate angle? Well, you set the angle with the sine bar, rotate your vise, use an indicator in the quill and scan along the sine bar. When there's no difference between the two sides, then the vise will be at that angle exactly. And then you can use that to mill your angled slot. Again, I'd like to point out that this is a 2 inch by 1 inch by 5 inch sine bar, and they make a very common 5 inch by 1 inch by ½ inch sine bar, and that's probably a little more useful inside the vise because if I put it sideways, you can see there's not much jaw height left. However, if you get extended jaws, then this will be just fine, and it'll give you a pretty decent platform to work from. It's not a coincidence that the distance between the center of the rolls is 5 inches and that most people's vices are 6 inches. This sine bar is made by Shars, or for Shars, and it has a stop that you can slide up and down on the end. It is very well made, and it's accurate to within 1,000th across its surface. I think they spec 10,000th across its surface, and they spec 2/10,000th. So it's well within their spec. It's very nicely ground, and I recommend it. Thanks for watching. Hope to see you next time.